We're going to talk about measures of central tendency and variation, section 11.5.2. So now we're doing the second half of 11.5. This is a lot more of the statistics part of the half, dealing with variation and standard deviation before. Now, John, you're in stats, right?
Yeah.
So you would have done some of this already.
Probably.
Okay. But measure of central tendency and variation today, section 11.5.2. First thing we want to talk about is the mean. The mean is the measure of central tendency. The variance and standard deviation are measures of dispersion or variation. What does the mean usually find? Mean finds the average, right? Okay. So we're going to talk today about finding the average. So the notation often used for the mean is X bar.
The hardest part of this is literally just learning the name of the variables.
Yeah, I know.
Like sigma and mu.
Yeah. So there's X bar. Then the variance is denoted by
Sigma. Variance, sigma squared.
sigma squared.
That's sigma.
Yeah, it's like a cursive level.
Because we're thinking it's not mu. Mu's the U, right?
It's like with cursive U.
Yep. So it's sigma squared. And the standard deviation is denoted by just sigma. Okay, now again, you look at those symbols and you're like, oh my gosh, this is crazy tough today. It's really not that bad. Okay, so the first thing we're going to do is we're going to talk about, well, just finding the mean. All right, so here's a pretty good example of all the steps you're going to have to go through finding this information. So the first thing you do is you need to find the mean. Well, that's pretty good because we've been doing mean since probably like 7th and 8th grade math, right? Add them all up, divide, you get the mean, you get the average. Okay, the next part here, you find the difference between the mean and each data value. So you take x minus x bar here. So again, you would take 6 minus 7, you get negative 1. 8 minus 7, and you get 1. 9 minus 7, you get 2. 8 minus 7, 1. And you keep going for every value, and you're subtracting to find the values. Now, I'm not too concerned with how you subtract. Because do you know why? Because the next part is you need to then square those values. So whether you subtract one way or subtract the other way doesn't matter, because when you square them, they're always going to end up positive. Because the negative times negative is a positive, positive times positive is a positive. So it doesn't really matter which way you subtract. Just subtract them, positive, negative, whatever you get, square the next values. So then you square all those values you had. For example, negative 1 squared is 1. 1 squared is 1. 2 squared is 4. 1 squared is 1.
Can't purposely.
So then we continue. And 0 squared, 0. Negative 2 squared, 4. Negative 1 squared, 1. 0 squared, 0. Negative 1 squared, 1. And 1 squared, 1. Okay? So you find all the squared values. Great. And then we find the variance. And how you find the variance is you add all of these squared values and divide it by the number of data values you have. So you add up 1 plus 1 plus 4 plus 1 plus 0 plus 4 plus 1 plus 0 plus 1 plus 1. You get 14 divided by 4. And my variance is then 1.4. And then to find the standard deviation. To find the standard deviation, you then take the square root of the variance, and you get approximately 1.18. Now, John, what is the importance of the standard deviation? Do you remember?
Bell curve.
Bell curve. Yeah, it all comes from the good old
We're going to use that now.
bell curve right there. Where, what's right in the middle there, John?
Sigma.
Okay.
Average.
Average right there in the middle. Then what's the standard deviation tell us there, John?
How many out it goes.
Yeah.
And there are 3 standard deviations in each.
You get like within 3 standard deviations of all sides are represent all of the data values. This leads into a lot of times like IQ scores. IQ scores are based off of this. Or what's in the middle? Do you anybody know?
128. 114.
100, I believe, is the middle based.
So,
I believe the 100's right here in the middle. But there's a lot of things based on the bell curve. And then the standard deviation is where your range of scores or everything else that wherever you're finding should be within. Everything's within 3 standard deviations. And then the vast majority of things, about like the first like 60% or something like that, is within 1.
yeah, it's like 38 and then like 60 something. And
Yeah.
98.
But again, it leads into some pretty cool statistics that John's pretty familiar with here. Okay? So the first thing we're going to do is we're going to talk about mean, median, and mode. Okay, good measure, central tendency here. The mean is the average. The median is the middle when they are set in numerical order. Big key there. They have to be set in numerical order. And then the mode is the one that occurs the most often. Take a couple seconds and try numbers 1 and 2. Find the mean, median, and mode of the 2 data sets. So let's look at these here. Number 1A, what's the mean of that first data value set? What's the mean, Andy?
5.25.
Nice job. What is the median of that set of values, Jack?
5.
5, nice job. And then the mode is what, Maddie?
5 and 2.
5 and 2. Can I have multiple modes? Can I have no modes? Correct. I can have multiple and I can have no modes. Number 2. What is the mean of that data set, John?
9.
9. What's the median, Mark?
5.
Close. It's 9.5 because when there's 2 of them in the middle, you add them up and divide by 2. We'll find the middle of those. And then the mode. Which one's the mode, Andy? 11. Okay. So mean, median, mode. Good. We're doing well there. We're going to skip number 3. I think we did pretty well. Now we're going to talk about find that standard deviation. Okay. So Dana's quiz scores are 2, 1, 5, 3, 1, 5, 3, and 4. Now you're hoping these are at least out of 5, right? Because if this is out of 10, Dana ain't doing too well. Okay. So first thing we're going to do is we need to find the mean. All right, so we're going to take all 8 of those and add those up. Okay, so 2 plus 1 is 3, plus 5 is 8, plus 3 is 11.
14, 19, 22, 26.
No, 24 I think is what we get. You add them up, you should get 24 divided by 8. The mean is 3. Okay, so you get 24 divided by 8, and you get a mean of 3. Next thing you can do is now you need to find the difference between the mean and the data value. Okay, so 2 minus 3 gets me -1. 1 minus 3 gets me -2. 5 minus 3 is 2. 3 minus 3 is 0. 1 minus 3 is -2. 5 minus 3 is 2. 3 minus 3 is 0. And 4 minus 3 is 1. Okay, so that's all the differences. Next thing I need to do is now I need to square those values. So -1 squared is 1. -2 squared is 4. 2 squared is 4. 0 squared is 0. -2 squared is 4. 2 squared is 4. 0 squared is 0. And 1 squared is 1. Okay. Now I find the variance. Well, how do I find the variance? To find the variance, I add up all of those values and divide it by how many values I have? 8. So 1 plus 4 is 5, plus 4 is 9, plus another 4 is 13, plus another 4 is 17, plus 1 is 18. So we're 18 divided by 8, which gets me a variance of 2.25. And then I find the standard deviation. And to find the standard deviation, I take the square root of that. So the square root of 2.25 is?
Wait, I got this 1.5.
It is 1.5.
Oh,
So that is my standard deviation.
It's 225.
Okay, so nice job. Again, as you look at this, is this really really tough math? No, not really. It's just, there's a long process that goes into it, right? Okay, and that's kind of the issue with this. It is kind of a longer process, and there is some work to be done. If you have higher numbers, think this is probably gets a lot tougher? Yeah, you bet. If your mean isn't a whole number, is that tougher yet? Yes. You get some tough ones that do come out. Okay. Let's try number 9 here. Take a couple seconds to try number 9. So the first thing you want to do, we'll go through steps. You want to find the mean. After you find the mean, you find the values minus the mean. And then you find the variance. Oh, sorry. And then you want to square those values. And then you find the variance. And then lastly, you'd find the standard deviation. Okay, so take a couple seconds to try this problem on your own. Let's look at this here. The mean is, what do we say? The mean is 5. And then I find x minus x bar, so I get 2, -1, -2, 4, and -3. And then I square those, so I get 4, 1, 4, 16, and 9. And then I find the variance. So to find the variance, add them all up. When you add them all up, what do you get? Sorry, add them all up first. 34. Ooh, not 24. So I get 34, and I divide that by 5, and then I get, what did you say? 6.8. So that's my variance. Then find the standard deviation. So the standard deviation, then I take that as 6.8, and I square root it, and I get approximately 2 point what? 2.61. Nice job.
You want to start rounding up to 100?
Hundredths is fine for right now, unless it says otherwise. Hundredths is good. Again, this is kind of important, not only for math, some applicable stuff, but NISA test. For sure, there will be some problems on NISA test dealing with standard deviation. Okay. Let's try number 10. I will tell you, number 10 is a little bit rougher. Do you know why?
Probably just
Because you get a decimal. Because the mean's a decimal. Yeah. So you want to find the mean again. Find x minus x bar. And then you want to square those values. And then you want to find the variance. And then you want to find the standard deviation. Okay. So take a couple seconds and try this. It is a little bit nasty. Make sure you do have the correct mean first before you continue on. What is the correct mean? 10.75. Nice job. Okay, so it is the correct mean. Go from there. Okay, so let's look here. When you subtract them, I think you end up getting negative 5.75, 1.25. What'd you say?
I'm just kidding.
Negative 0.75, 2.25. Negative 2.75, thank you.
I'm not adding.
0.25, 4.25, and then you end up with 1.25, right? And then you square all those values and you get some really nasty ones.
Yeah.
And then you add them all up and you get the variance. What's your variance come out to be?
I got 4, 8. Oh, just kidding. Hold on. I gotta go back. It was 14 something. Really?
I think it's 9, or 8 something, wasn't it?
I don't know. For that, so I got negative 1.
There's only, it can't be 14 because there's only 2 double-digit numbers and 2 numbers there at 106.
All right, now we have the variance. The variance is about 8.36. But then to find the standard deviation, then I take the square root of that 8.36, and I get approximately, what did you say, Lester?
2.89.
About 2.89 is that standard deviation. Nice job. Okay. And again, the key there is, when you're squaring those negative values, just, don't even include them because it's going to end up positive anyways.
Wait, hold up.
Here's
I think I should
your assignment.